Hello friends, today we'll be discussing about surface areas and volumes, maths topic, which is of class 10. Here we'll be discussing about various kinds of figures. We'll be discussing, and regarding that, we'll be discussing about the areas and volumes. Areas and volumes. In the areas, we have got curved surface area, and we have got total surface area. And we have got the volumes. So we'll be discussing about various figures. Let us start with the figures like cube first. In a cube, we have got a sphere kind of figure. Sphere has got 4 sides, and all the sides are equal. Length, we have got all sides are equal. So let us make the cube out of the sphere. How will we make it? So this is a cube which we have made. While making a cube, we know that we have got 6 sides in total because one on the front, side, back, and on this side. 4 sides, 1 top, 1 bottom. So in a cube, if we discuss about the total surface area, that is equal to, because we have got 6 sides in total, as we have discussed. So the total surface area is 6a square or 6l square. Anything we can take, 6l square. Okay. Now here we also have the curved surface area. What is the curved surface area? Curved surface area means we have got the 4 sides, that is front, side, back, and side. So the 4 sides, therefore we have the curved surface area of the cube as 4l square. Then we have the total surface area, curved surface area. After this we have the volume. Volume is equal to L cube, which is equal to L multiplied by L multiplied by L 3 times. Now the total surface area can be in centimeter square. Curved surface area can be in also centimeter square, and the volume will be in centimeter cube. So these are the units. The units can be in meter cube also in the case of volume. In the case of the areas, we can have meter square and meter square like that. So this way we can have. This is the cube. Okay. So now we'll be discussing about the next figure, which is cuboid. Now cuboid is a figure which is relating to a rectangle. So let us make a rectangle first. In a rectangle, you must be knowing that we have length, we have breadth onto the side. Also that if we try to make a figure like a 3D figure, will be in the form of a cuboid. So length, breadth, and height. This is the height, and this is the breadth. Here we have the total surface area. Total surface area of the cuboid, which is equal to 2 bracket LB plus BH plus LH. Here L is the length, B is the breadth, H is the height. So we have to multiply here, then plus, then multiply, then plus, then multiply, then overall multiply by 2. After this we have curved surface area, CSA. We also call it as LSA. We can say LSA also, lateral surface area. Anything we can discuss. Now in the case of lateral surface area, we have the side portions only. That is 4 sides. but we don't have the upper side or the lower side, because lateral means all the around sides, not the up, not the bottom. So therefore, we can say that the formula will be accepting this LB. LB will not be there because we have length into breadth on the top part and length into breadth in the bottom part being excluded, not taken. So 2 bracket BH plus LH. Right. So after this, we'll be discussing about the volume. Volume of a cuboid is equal to L into B into H. So length into breadth into height, we have to multiply, and we will get in the form of volume, which can be in the form of meter cube. This will be meter square. This will be meter square. So like that. So after this, we will be discussing about the next figure, which is right circular cylinder. So let us make a right circular cylinder. How we have to make it? Simply draw 2 parallel lines and make a circle on the top and make a circle at the bottom. You might have seen the cylinder in your home also. In the kitchen, you can see a cylinder is of this type. The red cylinder which you get in the kitchen, which you use for cooking purpose. So here we have got the height, that is from here till here. We have got the height. Then we have got the radius, and the whole is the diameter. The complete is the diameter. This much part, the half part is the radius. Okay. Now we'll be discussing about the curved surface area of the cylinder, which is 2 pi RH. This is the curved surface area of the cylinder. Okay. Now here it means that pi is what? Pi can be 22 by 7, or it can be 3.14. It can be any of these. Okay. So here we have the next one, which is the total surface area, TSA, which is equal to 2 pi r bracket r plus h. This is the total surface area. Here we have the radius. R is for radius, h is for the height. Then we have the volume. Volume of a cylinder is equal to pi r square h. So radius square into height. So we can apply the values, whatever value you may be getting here. You may get 2 as a radius, for example, height as 5. So you can put in these values and get the answer. We know that this is in the form of centimeter square. Anything centimeter square or meter square. This can be centimeter square or meter square. And this will be in the form of centimeter cube or meter cube. So is it clear to you, students? Okay, fine. So let us erase this now. Now we'll be also studying about the cylinder, which is a hollow cylinder, we can say. So let us study about the hollow cylinder. Now what is a hollow cylinder? Let me make a figure first. 2 parallel lines. Circle at the top, circle at the bottom. Okay. The meaning of hollow cylinder is that it is hollow from in between. There's nothing in between. So we can say that there can be 2 radius. This figure can be having 2 radius. One is small radius, that is from this point to here, and then from this point till the end, which will be capital R. So we have got 2 radius here. So let us say that here the area of the total surface area. What is total surface area in this case? Which will be 2 pi r, 2 pi r. Here we have to write down the capital R because the capital R is bigger than the smaller r. So therefore, 2 pi RH plus 2 pi small RH. So it means this is the total surface area of the outer part. Outer part means it includes the bigger radius. So the outer part total surface area plus the inner part total surface area. Also, we have to add this part. This is which is the additional part of the difference between two radius. This part and this part, you see, all the parts. So here it will be plus 2 pi r square minus r square. So this is how we find out the total surface area of a hollow cylinder. Now, why we have done these two? Because this was of the outer radius, which is bigger r, and this is of the smaller radius, which is the inner r, inner radius. So outer plus inner plus we have got pi r square. Why this is written? Because we know that the area of the circle is pi r square here also, and we have found out the difference, radius square minus radius square. So we get 2 pi, 2 because one circle, second circle. So therefore 2 pi. Okay. So friends, here we also will discuss about the volume. How will we find out the volume? Now, volume, you must be knowing that normal volume is pi r square h. This is the normal volume of a cylinder. But here we are discussing the hollow cylinder. So it will be the difference between pi r square h, the capital R, which is the bigger radius, and minus small radius pi r square h. We have to find out the difference between them. So this will show us the volume of the hollow cylinder. Is it fine, friends, students? Okay. So let us go to the next topic now. Now the next topic is regarding cone. Now cone means you must be knowing about the Joker cap, which is in the form of cone, or you can say a tent also. You might have seen the canvas tent under which some people live. So this is a kind of cone. We also know that this is the radius because this is a circle, and circle has got half part. This from the center till the end part, we have got the radius. We also have this is the perpendicular, we can say, or we can say as the height h, and this is the slant height. So we can say h is the height, and L is the slant height, and R is the radius. Okay, now here we'll be discussing about the total surface area. Total surface area of the cone. So let us say the total surface area of the cone, which is equal to pi r bracket r plus L. We have got the radius and we have got the slant. And what is curved surface area? That is equal to pi r L. So this is the curved surface area of the cone. Now, what is the volume of a cone? Volume. Volume is equal to 1 by 3 pi r square h. 1 by 3 pi r square h. This is the volume of the cone. Okay. So this topic you also know that This is in centimeter square, this is in centimeter square, and this can be in centimeter cube. If we have to find out the slant height and we are given the height and radius, it can be L is equal to root of x square plus r square. So this is the Pythagoras theorem being used because we know that this is a right angle triangle, this one. In a right angle triangle, we have to find out the hypotenuse, which is equal to L, is equal to perpendicular square plus radius. Is it clear, students? Okay. So let us move to the next topic now. Next topic is sphere. Sphere is a kind of a circle or a ball. You see, a ball has got a radius. If at all you are given the diameter, then you have to divide by 2 and you will get the radius. So diameter is equal to 2 times radius, or radius is equal to diameter by 2. Okay, now let us talk about the surface areas. We know that here in sphere we have only total surface area, not the curved surface area, because there is nothing in between. It is totally covered from all the ways. So therefore, we have only TSA. So what is TSA of a sphere? That is equal to 4 pi r sphere. And other thing we have is volume. Volume is equal to 4 by 3 pi r cube. Centimeter square, centimeter cube. Okay, students. So let us move to the next topic now. Next topic is hemisphere. H-E-M-I. Hemisphere. So hemisphere means it is a kind of a saucipan type, a kind of a katori, you can say. It has got the circle on the top. And we also know that there's a radius from the center because this is a circle on the top. So we have the radius. And this is also the radius. Because the circle has got from the center all parts equal to radius from the center till the circle part. So let us say what is the PSA first. PSA of the hemisphere, that is equal to, okay, PSA is equal to 3 pi r square and CSA is equal to 2 pi r square, and we have the volume which is equal to 2 by 3 pi r cube. So these are the formulas of a sphere. Hemisphere. Okay. Here we have a hemisphere in the form of a shell. It can be in the form of shell also because there can be space in between, and we can have 2 radius. So let us say hemispherical shell after this. Spherical shell. A hemispherical shell means it is a kind of hemisphere only, but only the difference is that, sorry, then we may have as like this. So from the center, we have one radius which is small r and the outer radius which is capital R. So this is known as hemispherical shell. Now here we have got the surface areas. How will we find out the surface area? Now it is 4 pi r square plus 4 pi r square. So why so? Because we have the outer radius which is capital R. So we have the outer part area, surface area, and this is the inner part surface area because we have got the smaller radius. So therefore, inner part surface area is this one. Outer part plus inner part. This is outer plus inner. So we get the total surface area. This is known as TSA. Also, we can find out the volume of this hemispherical shell in the same manner. Volume. Volume, we know that it is 4 by 3 pi r cube. So we can write down as 4 by 3 pi in bracket because we have got 2 r. Therefore, r cube minus r cube. So this is how we find out the volume because we have got one outer radius, other inner radius. So therefore, we use them same manner. This can be in centimeter square. This can be in centimeter cube. So is it clear to all of you, students? Okay. So now we'll be discussing about different kind of surfaces being used. Let us know the combination of volumes and surface areas of different figures. So after this, combination of surface areas and volumes. Now here we are discussing about the first type. The first type consists of a cylinder, which is of circular part on the top and circular part on the bottom. And on the cylinder, we have got a cone. For example, there is a cone placed here. So we can say the combination is cylinder plus cone. Cylinder, the bottom part, and the cone, the upper part. We also know that since this is a combination, so therefore we can say that the radius of cylinder and the radius of cone must be same. Because the radius of cylinder and cone is in combination. Now, the height of this cone is h. You know that here also this is a different height to the height of the cylinder. And we can say that if at all, we can say that this is h2 and this height is h1 and h2. We have got two heights, h1 till here and h2 starting from here till on the top. So in total, if we can say the total height of the object, this is equal to h1 plus h2. The total height, h1 for cylinder, h2 for the cone. Together that is the height if we are asked to find out the total height. Now, if at all, we also have like to find out the total surface area. Let's find out the total surface area. This figure, TSA. Total surface area will be TSA of cone plus TSA of cylinder plus area of circular base. So here we have three things. TSA of cone, because we know that only the outer part of the cone can be seen, not the circular part, because it is connected to it. So CSA of cone, outer part only. And CSA of cylinder, which is only the outer part. We cannot see the inner part. Circles, we can't. This circle we can't see, but we can see the circle from the bottom. So therefore, we can say that area of one circular base, only this one is required. This is not required because this is connected with the cone. So therefore, we can't see the circle. We can see this circle only. So therefore, area of circular base. Now here we are discussing about the CSA of cone. we also know that CHF pi RL, and CHF cylinder. That also you know the formula 2 pi RH is CHF cylinder, and the area of circular base, which is pi r square. That you know, area of a circle is pi r square. So ultimately, we have to add all of them, find out all of them, calculate, and then add them. We will get the total surface area of this particular figure. Is it clear to all of you? Okay. So here we will also discuss about the volume of this figure, or we will have to find out the volume. So let us see. The volume, you know, it means the volume of cylinder plus volume of cone, because both are connected. So we can say that volume of cylinder plus volume of cone. So these two figures, we have to find out the volume. Okay, and you also know that volume of cylinder is pi r square h, and volume of cone is 1 by 3 pi r square h. So we have to combine them together. That is, find them separately and add them. We have to add them so as to get the total volume of the figure or the object, whatever is given. Right. Clear to you, students? All right. So next. Now in the combinations, we will discuss about the next part of combination, which consists of a hemispherical bowl this is a hemispherical ball, and on the top we have a cone. We also know that this is the height of the cone, this is the height of the cone, and this is the radius of cone also, and hemisphere also, because both are connected with this circular part. So therefore, the radius of both of them will be same. And here the line height is L, which if not given, you can find out by the Pythagoras theorem, as I've explained you in the cone part. Now we will discuss about the total surface area. How will we find this? TSA. TSA of this total figure will be TSA of cone plus TSA of hemisphere. So both the figures, we have to find out the total surface area. Here, after discussing about the surface areas of both of them, this is curved surface area. Both of them, we have to add. What is curved surface area of the cone, which is equal to pi r L, and curved surface area of the hemisphere. We have to add them together, both of them. Hemisphere curved surface area is 2 pi r squared. So we have to find out the values separately and add them, and we will get the total surface area of the figure. Also, we can find out the volume also in this manner. If at all we have to find out the volume, so volume of cone plus volume of hemisphere, we have to add them together. So let us write down the volume of these two figures separately. Volume of cone is equal to 1 by 3 pi r square h, and volume of hemisphere is equal to 2 by 3 pi r cube. So we have to find out the volume of both of them separately and add them. This will be the volume of the total figure. Right. So is it clear, students? All of you? All right. So let us move to the next part. Next combination. The next combination is a different one. Here there is not an attachment but a cavity. We can say that conical cavity in a cylinder. So let us make a cylinder first and then make a cavity. We have to make two parallel lines, circle on the top, circle at the bottom. Okay. After making this, we have to make a cavity. Cavity means a kind of a cutting is done. It can be cutting in the wood or any other material. So this is a cavity. Cavity means, for example, this is a stem. This is stem of a tree. Okay, and then there is a cutting done from in between. This wood has been removed. From this particular stem of the tree. So we can say that the cavity remains this part only, which is shaded. I will shade it so that you will understand it separately. This shaded part is the cavity, which excluding cavity. This has been removed, and we have only the shaded part. So we have to find out the surface areas and volumes of this part. How will we do it? We know that this is the height. This total is the height, and this is the radius. Here also at the bottom also. Still here because this circular part. Okay. Now we have to find out the total surface area. Let us see how to find out. This will be equal to curved surface area CSA of cylinder plus area of the bottom of the face of the cylinder. Area of base of cylinder plus CSA of cone. So we have got three parts. One is the CSA of cylinder. CSA of cylinder, you know, surface area, which is equal to 2 pi RH. And then we have got the area of the base. Area of the base means it is this one, which is pi r square. And then we have the CSA of the cone, which is pi r. So we have to find out the CSA of cylinder, which is the outer part of the cylinder, circular part. Not the base, not the top one, nothing. Only the outer part. Because this is cavity has been taken out. So therefore we can say that this wood has been taken out. So top portion is not there. So therefore we are not including this. We are including the bottom part because this base is there. Still there. Okay, so area of the cylinder, base of the cylinder, which is pi r square, this part. And we have the CSA of the cone, which is pi r. This is the cone, which is the inner part. So we have to add them together and get the total surface area of this particular figure. So is it clear to you, students? Right. So we can move to the next topic now of combinations. So the next topic consists of cones on either side of the cylinder. In the sides of cylinder. So let us make a cylinder first, and then we'll make the cone as way of fixing it, the cylinder. So we are making a slanting kind of horizontal type of cylinder. So let us say that this horizontal type, circular ends, and then we have got the cones on the either ends. Cones means here also, and here also. So we can say that the radius is same on both the sides, this side also, because radius is of the cylinder on both the sides. And the height will be the height of the cone and this height of the cone. So we can say two heights. One height this, and one is the height of the cylinder. So we can say that, let us take this as H1 and this as H. So we can say it is the total height will be equal to H1 plus 2H. H1 is only cylinder height, and 2H means one height of this cone, one height of this cone. These are same, so therefore 2H, two cones. So this is the total height. Now for finding out the surface area, total surface area, let us see how will we find out. TSA. TSA will be CSA of two cones. So CSA of cones, that is pi RM. So we have to multiply by 2 because we have two cones. And then we have TSA of cylinder. And CSA of cylinder is 2 pi. So 2 pi RL plus 2 pi RH, we have to add them together so as to get the total surface area of this figure. Also, students, we can find out the volume also in the similar manner. Let us say how to find out the volume. Now, volume, as volume will be of same way, two cones plus cylinder. Now, two cones volume means, the volume of one cone is 1 by 3 pi r square h. Okay, here h is this one, right? So we have to multiply this by 2 because we have got two cones plus cylinder CSA, cylinder volume, which is pi r square h. Pi r square h1, it will be h1 because this height of cylinder is h1. So we have to find these values and add them together. This way we can find out the volume of the total object which is passed from you. It is a 3D object which may be in the form of any figure, can be wood, can be metal, or anything. Okay, students. So is it clear to you? All of you? Okay. So let us move to the next topic now. Next topic is cylinder with hemispherical end. So let us make cylinder with hemispherical ends. So let us make the figure first. Making two parallel lines, circular ends, and hemisphere on the top. 1 and 2. So we have got cylinder and two hemispheres. We can say that this is the height of the cylinder, and this is the radius, and even this is also the radius. The radius is from all the sides, from the center till the circular part. Here also we can say this is the radius. This is also there. You must be given radius in the question only, so you can find out the values in it. Now, when we have to find the total height means this radius plus this height of the cylinder. So that will be the total height of the figure if it is required. Now, first of all, let us find out the TSA. Total surface area of this figure, this particular object. It can be gulab jamun. You might have seen in the market. Gulab jamun can be of this shape. So, cylinder and hemispherical ends on both sides. Okay, TSA. TSA will be equal to CSA of cylinder and plus CSA of two hemispheres. So, what is CSA of a cylinder? You know that it is pi r square h. So, pi r square h. And the CSA of these particular hemispheres 2 by 3 pi r square. Sorry, this is 4 pi r square. Because we have two values, so therefore I am multiplying 2 multiplied by 2. It is actually 2 pi r square, but if we multiply with 2, we will get 4. So therefore I am writing 4. You can write on brackets 2 multiplied by 2 pi r square. So like this. When we multiply, we get 4 pi r square. 2 pi r h. 2 pi r h plus 2 pi r square. So when we add them together, we will get the total surface area. Similarly, volume can be taken out. Volume is equal to volume of cylinder and volume of two hemispheres. The volume of cylinder, you must be knowing, it is pi r square h. And we have two hemispheres. 2 hemispheres means 2 multiplied by 2 by 3 pi r cube. So we have to find out these two values and add them together so as to get the total volume of this particular figure. So this is how we can find out this value. Okay, is it clear to all of you? Right, so let us move to the next topic now. The next topic is hemispherical cavity in a cylinder. Okay, here cavity, we have already discussed about cavity. Cavity means something, some part of it taken out with the help of some machines or something like that. So we can say that, as we have discussed, that cylinder may be in the form of a stem of a tree. Stem of a tree is in a kind of cylinder only. And if we try, this is a wood, and if we are making a cavity in it, cavity is in the form of a hemisphere. Hemisphere means it is like this, semicircular type thing. This type of cavity is taken out. So if this cavity is taken out, we can say what is the remaining part. The remaining part is shaded, which I am shading here. This is the remaining part. After taking out this particular part, we are remaining with this part only, which is shaded. So the height remains the same. The height of the cylinder. The radius remains the same. Radius only. Okay. Now here, if we try to find out the total surface area, TSA, that will be equal to CSA of cylinder, CS of cylinder, then plus we can say CSA of hemisphere. Okay, CSA of hemisphere. And also we can say that plus surface area of base. Because here we have got CSA of cylinder means only the side portion. We have taken the side portion. We have also taken the CS of hemisphere, which is the this part. This part we have already taken the second plus. Third, surface area of the base. This base is not taken from bottom. We also can see this. This is visible. If we try to turn out the figure, any wooden part, then we can see the wooden part at the bottom. So that is surface area of the base, which is a circular part. So here we are discussing about the CSF cylinder first. So you know CSF cylinder is equal to 2 pi RH, 2 pi RH, and CSF hemisphere, hemisphere CSA, that is equal to 2 pi R square, and then surface area of the base. Okay, surface area of the base, that is equal to pi R square. You know the circular part, which is area is circle only. The circular part is pi R square. So we can add them together and get the total value of the this cylindrical part where a hemispherical cavity has been taken out from here. So we have to add them together. Is it clear? Is it clear to all of you? Okay. So let us move to the next part. Here the next one is hemisphere on the cube or on a cuboid. So let us make the hemisphere on the cube first. Let's see how to do it. Hemisphere on the cube. So let us make the cube first. Now, this is a cube and a hemisphere has been fixed on it. If we fix a hemisphere, it will look like this. So hemisphere has been fixed on the top. So there is circular part at the bottom, so we can see the circular part which is like this. This is a cube. So we know that the total surface area of this would be TSA will be equal to the TSA of cube and minus area of the hemisphere face, area of hemisphere, area of the hemisphere face, and plus curved surface area of the hemisphere, TSA of hemisphere. I'll discuss with you what does it mean. Actually, here we first take the total surface area of the cube. As we know, the total surface area means everything. This cube, it consists of only the total surface area of the cube. But we also know that this hemisphere has been fixed on the top. So this particular circular part at the bottom, which is fixed on the cube, cannot be seen. It is fixed on the this top part of the cube. So we can say this is a circular part. Since it cannot be seen, so we can say that it has to be subtracted. So this part has to be subtracted. Then we have got the CSA of hemisphere. Hemisphere CSA means it is the top portion. This top portion CSA. Okay, so now let us write on the formulas of which is equal to total surface area 6 hemisphere minus area of the hemisphere base, which is the bottom part, which is pi r square. It is circular part, you know. And then we have the CS of hemisphere. CS of hemisphere is 2 pi r square So we have to add this part. So this way we can find out the total surface area of this particular figure. Students, you can ask me your doubts in your comments, and also you can say anything about this. If at all you find something difficult, you can ask me by making comments. Now here also we are going to find out the last part is the volume also. Let us see how to find out the volume. Now the volume consists of volume of tube and then we can say that volume of hemisphere also. Volume of tube, you know that it is A cube or L cube, and the volume of hemisphere, which is 4 by 3 pi r cube. So like this, we can find out the total volume of this particular part. So any doubts you can ask me, and I think we can finish over here, and you can ask me your doubts. Thank you so much.